I'm Fred Van Der Merwe from CAD Pro CAD Group. In the following video, I'm going to demonstrate some fantastic new features in Inventor 2027. Specifically, we'll look at the Autodesk Assistant with voice prompting, how the parameters tool is now modeless, and a quick rule with the new iLogic codeblocks interface. Of interacting with the new Autodesk Assistant, I'm going to start off by creating a new file and saving it as lbracket.ipt. Then this next trick was a game changer for me. The Windows button in H enables Windows speech to text. So once I have Autodesk Assistant open over here, and I click in the region for text input, I'll speak my instructions and have it appear here in real time. Please turn on the visibility of all origin work planes, then select the XY plane, rename that to mid plane. Press enter and voila. It talks me through the process and it does the things I'm asking it to. The plane's visibilities have been turned on. And there we can see, it's renamed the XY to mid plane, and we can see that's previewed there. So that's just to show the simple functionality of it. Let's step it up a notch and we give it its next instruction. I'm going to ask it to create a bunch of generic user parameters for my intended design and modeling this L bracket. Please create a bunch of parameters for an L bracket in this currently opened part file. These should include a parameter for number of holes and an extrusion distance, as well as things such as flange width, flange length, web thickness, fillet radius, hole diameter, and hole edge offset. There we go. A bunch of parameters created for me without me typing a single thing. And then we get to work modeling the cross section of my L bracket. The next thing I want to show here is how I'm able to keep working with my parameter table open. Create an additional parameter for hole pitch at 10 millimeters. There we go. The functionality of being able to give the Autodesk Assistant voice commands and keeping the parameters dialog open while working on my design makes design very quick and easy using the parameter table. Next, let's create an iLogic rule using codeblocks. What I want to establish in this component is that the extrusion distance parameter governs a couple of other changes. So at the current extrusion distance that we have here of 50, we want 3 holes at a 10 millimeter spacing. If it's anything larger than that, then we'd like to go to 5 holes. And if it's anything less than that, we want to go down to 1 hole. So we may want to change the spacing as we go up. So I'll set a variable for that too. So let's start off by establishing the conditions that we've got. I'll create an if rule and then embellish it. Add an else if, which is going to be our greater than scenarios, and then I'm going to do a catch all with the else that says if it isn't equal to or greater than, i.e. the less than values, what I set as else will be the catch scenario. So I want to apply the logic that if this, then that. Under logic, I can bring in the block that has the relationships variable. And in there, I can place the parameter that I want to control. Finally, I want that parameter to equal a certain number. So in the math, I just bring in our most simple variable for numbers. So the parameter that I want, all of the parameters I've created are user-based parameters, so I can filter it down to those, making that a whole lot easier, and say that I want the parameter extrusion distance. We use actual values, so I'm saying if the extrusion distance equals 50 as it currently does, then I want to set certain things. I want to set the number of holes, and I want to set the hole pitch. So here, okay, I'll choose my parameter, number of holes, and I'm going to choose the hole pitch. I'm happy with the number of holes being 3 as is currently defined, and the pitch being 15. Additionally, because I'm going to have some scenarios where features might be turned off, I want to set that both my extrusion and my pattern are not suppressed. So I would say I want a hole and the pattern suppression to be false, suppression to be false. Now there we've established our current regime. Else if, this is where I can just repurpose what I've done here already. I'll just hit Control C on that top block and Control V to copy it. We'll say if the extrusion distance is greater than 50, then what should happen? Well, we may want this to occur, this to occur, this to occur, as well as this to occur. Now here, what we're saying is, if we're greater than 50, we want to increase our number of holes to 5. And let's change our pitch to 12. And we would still like both of these features to be active. That's why we say suppression is false in both cases. Finally, if it is neither of those values, so if it's not 50 or anything greater, then it would be something less. So I'm going to say under the else if, I wish to set that rectangular pattern would be suppressed and we would only have one hole. So that is true. look at our model, and we save this rule. But we can see that this is all the code that was generated. It may seem like Chinese or gibberish to a lot of people, which is fine, because now with code blocks we don't need to understand what's going on there. This is all intuitive and graphical. Now, to bring out our parameter table, if we're to change our extrusion from 50 to 49, we can see that our pattern is suppressed and we only have one hole. As if we were to go to 60, you can see that our pattern is increased to 5. And we now have 5 holes. I'm sure there are much better and more elegant ways of doing what I've just demonstrated. But the point is that the graphical interface added to iLogic with code blocks means more people will now be able to start creating their own iLogic rules, and that's great. Thanks for watching.